geometry students, to the homework help video, page 302. Let's go ahead and get started with the help video. Let's start off with number one. Number one says to identify the pair of segments or pair of angles as bases or consecutive sides or legs or diagonals or base angles or opposite angles. Okay, so here we go. Let me get out my red pen here. We're dealing with QR and PS. Well, we've learned that in trapezoids, the parallel sides are called bases. So these two sides here are called bases. Okay? Alright, letter B, we're dealing with PQ and RS. Well, we've learned in trapezoids, the non-parallel sides are called legs. So these two segments here are going to be called legs. Okay? Moving on to letter C, we're dealing with PQ and QR. Okay? Now, those two sides are what we call consecutive sides, okay? Because they're touching each other. They're two sides that are side by side, okay? So, they are called consecutive sides. This is a leg here. This is a base here. And so these two sides are called consecutive sides, okay? Alright. Moving on to letter D here. Okay, we're dealing with QS and PR. Okay? And those are called diagonals. Okay? Diagonals. So there we go. Okay? Diagonals. Okay, let's move on to okay, guys. Okay, students, I'm back. The program for some reason just shut down on its own. So, okay, we just did this one here, and now we're moving on to angle Q, this angle here, and angle S. Well, guys, they're opposite angles, okay? They're across from each other, so we call those opposite angles, okay? All right, moving on to letter F, angle S. Right here, and angle P. Well, students, listen, this is one of the parallel sides. And what we've learned about trapezoids is the two angles that are on the end of a parallel line are called base angles. Okay? So those two angles are base angles. Okay? Alright, let's continue on. Let's take a look at number 2. Numbers 2 through 6, the directions say to use the words always, sometimes, or never, okay? Always, sometimes, or never. So, a trapezoid is a parallelogram. Is that always true, sometimes true, or never? Well, guys, think about it. A parallelogram means you have two sets of parallel sides. That's what a parallelogram is. So there's no way, never, there's no way a trapezoid can ever be a parallelogram, because the definition of a trapezoid is you have exactly one set of parallel sides, and the definition of a parallelogram is you have two sets or two pairs of parallel sides. So no, never can that happen. A trapezoid can never be a parallelogram. Okay, number 3. Okay, we did number 2. Let's take a look at number 3. The bases of a trapezoid are parallel. Now, let's think about that for a second, okay? We know by definition the bases of a trapezoid are always parallel. So that's going to be always. Okay? We learned that when we studied trapezoids. We said the parallel sides are always called the bases. So the bases of a trapezoid will always be parallel, because that's the definition of the bases of a trapezoid. The bases of a trapezoid are the parallel sides. So always. Okay, moving on to number 4. The base angles of an isosceles trapezoid are congruent. Well, it depends. Now think about it. If you're dealing with an isosceles trapezoid, here's a parallel side, here's a parallel side, here's a congruent side, here's a congruent side, then yes, the base angles are congruent. However, if you're dealing with a non-isosceles trapezoid, one that looks like this, then no, the base angles would not be congruent. So it's not always, and it's not never. It's some. Oh, it does say isosceles. My bad, guys. Feeling pretty dumb about that. I did not see the word isosceles here. The base angles of an isosceles trapezoid are always congruent. Yes, always. Okay, moving on to number 5. Number 5, the legs of a trapezoid are congruent. The legs of a trapezoid are congruent. Now, we know if you have an isosceles trapezoid, the legs have to be congruent, okay? Now, if you don't have an isosceles trapezoid, then the legs are not congruent. So, I'm going to go with sometimes, okay? If you have an isosceles trapezoid, then the legs will be congruent. And if you do not have an isosceles trapezoid, then the legs will not be congruent. Alright, number 6, the length of the midsegment of a trapezoid is half the sum of the lengths of the bases. That is always true. In fact, that's a theorem. I'm going to read the theorem to you right now. The theorem says the midsegment of a trapezoid is parallel to each base, and its length is half the sum of the lengths of the bases. So that is always going to be true. Okay, always. Okay, moving on now to numbers 7 through 10. Numbers 7 through 10, here we go. Decide whether you are given enough information to conclude that ABCD is an isosceles trapezoid. Okay, let's start off with number 7 right here. Okay, we have ABCD, and we know that AD is congruent to, let's say ABCD. AB is parallel to CD, and AD is congruent to BC. Alright, now, no, you do not know that you have an isosceles trapezoid at all. Here's why. Watch this carefully. No, you do not know for sure. Here's why. A, B, C, D. Now watch carefully. I know my drawing's not drawn perfectly to scale, but look. AB is parallel to CD. AD is congruent to BC. Well, it might be a trapezoid, but it might also be a what? A rectangle. It might also be a what? Square. And guys, a rectangle and a square can never be a trapezoid, because a trapezoid has exactly one pair of parallel sides. This thing here has 2 sets of parallel sides. I drew it on purpose. 90 degrees here, 90 degrees here, 90 degrees here, 90 degrees here. So no, you do not have enough information to know for sure that you have an isosceles trapezoid. How do I know that? I just gave you a counterexample right here. I just gave you an example that matches all of this information, but it's not a trapezoid. Okay, number 8. AC is congruent to BD. Angle A is not congruent to angle C. Alright, here we go. Now watch this carefully, please. A, B, C, D. Now let's draw AC and DB so that they're congruent, okay? There we go. Now, I wonder if I can, I was trying to think if I could use the tools on this mimeopad to do something, but anyways, never mind. Look, this right now is a trapezoid, so you're saying yes, we have enough information, but hold it, hold it, hold it. Now remember, all that we know is that AC is congruent to DB, okay? And I've drawn that the best I can, and this angle here is not congruent to this angle over here. But hold it, if I do one thing, now think about it, guys. See this line right here? Does it not make sense that I could take this line and not lose the, I really should draw one line. Hold on a second here. I'm going to draw one line instead of a bunch of little lines. Now, watch this. Does it not make sense, students, that I should be able to take this line here and without changing the length of it, slide slide it down to here just a little bit, okay? And then I can take this length here. Now remember, when I slid DB down, I kept it the same length as AC, okay? And then take this line here. Take AB right here. And just kind of go down like this. And there you go. So I still have DB congruent to AC, but this side here is not parallel to this side over here, and this side here is not parallel to this side here. I do not have a trapezoid, but yet this figure here satisfies all of these. AC is congruent to DB, angle A is definitely not congruent to angle C, yet I do not have a trapezoid. So you do not have enough information here for number 8 to say for sure that you have an isosceles trapezoid. Okay, let's say that we have angle A congruent to B. Let's go ahead and draw. Let's draw this. A, B, C, D. So we know A is congruent to B. I'm going to call this 90 and 90. I know D is congruent to C. I'm going to call that 90 and 90. Now, this figure here, students, look, totally satisfies everything here. Is A congruent to B? Check, yes. Is D congruent to C? Check, yes. However, do I have a trapezoid? No, I have a rectangle, and a rectangle is a parallelogram, and a parallelogram is never a trapezoid because a parallelogram has 2 sets of parallel sides, and a trapezoid only has 1 set of parallel sides. Not enough information. Number 10, AB is parallel to CD. Alright, so here we go. Let's see, how can we do this? Okay, now students, remember, we're trying to see if we can draw an isosceles trapezoid, or no, I'm sorry, we're trying to see if we can only draw an isosceles trapezoid. Well, look, here's AB parallel to CD, okay? So here's A, B, C, D. Now this figure right here is obviously not an isosceles trapezoid. However, does this figure meet all of the requirements over here? Well, let's see. AB parallel to CD. Yeah, it looks pretty good. AD is not parallel to BC. Well, that's true. There's no way this side here is parallel to this side here. So this figure here meets all the requirements given over here. But do I have an isosceles trapezoid? Not at all, no. So all 4 of these, 7, 8, 9, and 10 were not enough information. Not enough information. Okay? Alright, let's continue on. And once again, my program keeps shutting down, so not sure why it's doing that, but let's go ahead and continue on now to numbers 11 through 14. The directions say each figure has at most 1 pair of parallel sides. Decide whether the figure is a trapezoid. If it is a trapezoid, is it an isosceles trapezoid? So the only thing we know is we have exactly 1 pair of parallel sides, okay? That's all that we know is one pair of parallel sides, okay? Now, obviously, in this figure here, the parallel sides are here and here, okay? So do we have an isosceles, do we have a trapezoid? Yes, we do have a trapezoid, okay? However, and I think I read the directions wrong. Okay, each figure has at most 1 pair of parallel sides, at most. Okay, so they might have no parallel sides. At the most, they'll have 1. Now, how do I know these 2 sides are parallel? Because we learned that when 2 lines are perpendicular to the same line, they're parallel. That's an old theorem we learned earlier this year. When 2 lines, this line and this line, are perpendicular to the same line, then these 2 lines here are parallel. So we do have 2 lines that are parallel, okay? And so we do have a trapezoid, trapezoid, yes. But is it isosceles? No, not at all. There's no way this side here is congruent to this side over here. So no, it is not isosceles. Yes, we have a trapezoid. Yes. No, it is not isosceles. Okay. Number 12. Well, I mean, guys, look, we have no way of knowing if we have any parallel sides at all. So I'm going to say, no, we don't have a trapezoid, so we definitely do not have an isosceles trapezoid. Okay? No trapezoid as far as I can tell. Number 13. Now, let's see what we have here. Look at this, guys. Look at this. We got a line here and a line here cut by a transversal. Look at this. This angle here is congruent to this angle here. See that? Remember, anytime alternate interior angles are congruent, then the two lines are parallel. Remember that? We learned that earlier this year. Whenever two lines cut by a transversal have alternate interior angles congruent, the two lines are parallel. So I know this line is parallel to this line, so I definitely have a trapezoid. And yes, I also have an isosceles trapezoid because my legs are congruent. 2 marks here, 2 marks here. So yes, I have a trapezoid, and yes, it is an isosceles trapezoid. Okay, number 14. Okay, let's take a look at this here. We learned that whenever, let's see here. Now, students, somehow we have to come up with a way of proving that these two lines here are parallel. Now, common sense tells us they are, but still, we got to somehow say this thing here, that line there and this line here is parallel. Well, let's go ahead and use some numbers. This angle here looks like it's about 100 degrees. Now, if that's 100, this over here has to be what also? 100. And remember, inside a quadrilateral, the total angles are always what? 360, we learned that. So that means down here, these two angles have to be 160 together, and they're congruent. So this has to be 80, and this has to be 80. In other words, look, this angle here and this angle here are supplementary, and we learned that when two lines cut by a transversal, right here, have consecutive interior angles that are supplementary, then these two lines are parallel. Okay, so yes, this line here is parallel to this line here. And you might say, Mr. Earhart, you can't do that because you just made up a number like 100. Guys, it doesn't matter what angle you put in here. Okay, put 120 in here. I don't care. Let's call this angle 120. Call this angle 120. Okay, 120 plus 120 is 240. We know that all four angles have to add up to 360. Subtract 240. You're left with 120 for these two angles here, and they're congruent. So one has to be 60. One has to be 60. And look what you have. You have 120 here. You have 60 here. These two angles here are still supplementary. They still add up to 180. So we definitely have a trapezoid. Okay, no doubt about that. We have two parallel sides. So the question is do we have an isosceles trapezoid? Well, remember we learned something. It's a theorem that we learned. And the theorem is if a trapezoid has one pair of congruent base angles, it's isosceles. So do we have a trapezoid? Yes, because this side here is parallel to this side here. And do we have at least one pair of base angles congruent? Yes, we actually have two pairs. So yes, it is an isosceles trapezoid, definitely. And the theorem you have to remember is if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid, okay? Alright, number 15, find the measure of angle, or find the length of EF. Okay, well look, there's 2 marks here, and there's 2 marks here, so we know these two sides are congruent, so EF equals 3. Now, find the measure of angle M. Well guys, this is an isosceles trapezoid, okay? We know it's a trapezoid because it says it right here. We know it's isosceles because of the two congruent sides. Well, in a trapezoid, because this line, this side here, is parallel to this side here, these two angles here will always be supplementary. They're consecutive interior angles. So, if this is 60, this has to be 120. Okay, so the measure of angle E equals 120 degrees. Next, I want to know the measure of angle G. Well, guys, look, if you have an isosceles trapezoid, base angles are congruent. So if this is 60, then angle G will also be 60. So the measure of angle G equals 60 degrees. Now, find the length of the mid-segment, okay? Let's go ahead and draw the mid-segment. Alright, let's find the midpoint here. The midpoint looks to be about right there. And the midpoint looks to be about right there. So here's the mid-segment, okay? Now remember, how do you find the length of a mid-segment? You add the two bases together and divide by 2. So, 5 plus 2 is 7. 7 divided by 2 is 3.5. So the length of the mid-segment is 3.5. Okay, moving on to number 16. Okay, we have here, let's see. They want us to find the measure of y and the length of the mid-segment. Now, first of all, we don't know anything about this thing. Is it a trapezoid? Well, sure it is. Remember, if two lines are perpendicular to the same line, then those two lines are parallel. So we know for sure this line here is parallel to this line here. So we have a trapezoid. Now, find the measure of angle y. Okay? Well, think about it for a second. We know all four of these angles have to add up to 360. We also know this. This angle here with one dot and this angle here with one dot have to be supplementary. They have to be. Guys, look, you have parallel lines being cut by a transversal. Anytime you have parallel lines being cut by a transversal, the consecutive interior angles will always be supplementary, always. So this is 45 right here. Then this right here will be 135. So the measure of angle y equals 135. Now, find the length of the mid-segment. Well, once again, here's the midpoint of your leg. Here's the midpoint of your leg. Draw the mid-segment. How do you find the length of that line? You add your two bases together and divide by 2. So, 3 plus 6 is 9. 9 divided by 2 is 4.5. So the length of the mid-segment is 4.5. Alright, moving on. Okay, numbers 17 through 24. We're going to decide whether it's possible for a trapezoid to have the given property. Alright, let's start with number 17. Bisecting diagonals. Okay, well, let's go ahead and get a new page up here. Number 17 is bisecting diagonals. Is it possible to have a trapezoid in which you have bisecting diagonals? Let's take a look at it and let's see. Let's go ahead and draw a trapezoid, okay? And then we're going to draw the diagonals. Now, if the diagonals bisect each other, that means this segment here is congruent to this segment here. And that means this segment here is congruent to this segment here, correct? That's what bisect means, okay? Now, we know by vertical angles, this angle here has to be congruent to this angle here. So look what you have, students. You have congruent triangles. That means this triangle here is congruent to this triangle down here. Now, I know they don't look congruent, but hear me out. Okay, now, if that's true, if these two triangles are congruent, then that means by C, P, C, T, C, this side here is congruent to this side here. Whoa, Nelly, hold on a second. That's impossible. Guys, think about it. You can never have a trapezoid that has congruent bases. Think about it. Look, let's say this is a length of 4, and let's say this is a length of 4. Now, I know they're not very good-looking lines. Let me change this real quick. Okay, I want you to see this. Okay, here's two perfectly congruent lines. Now look, if those are your parallel lines, your bases, if you connect them, you're going to have a square or a rectangle, okay? You say, well, Mr. Earhart, move one of them over. Fine. If you move this over or down, it doesn't matter. These two sides here are still going to be parallel. You're going to have a parallelogram. It is impossible to have this side here, a base, congruent to this side here's it's impossible. If that happens, then you don't have a trapezoid. You have a parallelogram. So no, the diagonals will never bisect each other. Okay, let me go over this again real quick. Real super fast, okay? Look, diagonals cannot bisect each other because in a trapezoid, if they did, this would be congruent to this. This would be congruent to this. We know this angle is congruent to this angle because vertical angles are congruent. You've got side angle side congruent to side angle side. That means this triangle here with the 1 in it is congruent to this triangle here, and that means this side here is congruent to this side here, and that's impossible. You cannot have congruent bases. So no, it is not possible to have a trapezoid that has bisecting diagonals, okay? All right, number 18. Let's cross these off as we go. Number 17. All right, number 18. Can you have congruent diagonals? Well, definitely yes. I'm not even going to waste my time drawing that. That's a theorem that we learned. Remember, whenever you have an isosceles trapezoid, the diagonals are congruent. So is it possible to draw a trapezoid that has congruent diagonals? Yes. An isosceles trapezoid, most definitely, yes. It is possible. We learned that, okay? Okay, cross off 17, cross off 18, number 19. Can you draw a trapezoid that has one pair of congruent opposite angles? One pair of congruent opposite angles. Well, let's see. Here we go. Let's go ahead and draw a trapezoid. And just for the fun of it, there's no way these angles are congruent. But we're going to call this 100, and we're going to call this 100. Now there, do you see what I've done? These opposite angles are congruent, okay? Now, this is parallel to this trapezoid. So I've drawn a trapezoid, and I'm claiming that these opposite angles are congruent. Now, if that's true, then what does this angle here have to be? 80. Remember, whenever you have a trapezoid, the two angles here are always going to be supplementary, and this would have to be 82. That's impossible, guys. Look, what do we know when opposite angles are congruent? What do you have? A parallelogram. We learned that whenever both sets of opposite angles are congruent, you have a parallelogram. So if these two angles here are congruent in a trapezoid, then these two angles here also have to be congruent, and then it can no longer be a trapezoid. It has to be a parallelogram. So no, it is not possible to draw a parallelogram or a trapezoid that has opposite angles congruent. Okay, I'm back. That's the third time my program has shut down on me, so I hope this is not going to continue. Okay, but no, it is not possible to have one pair of congruent opposite angles. No, that is not possible, okay? So that's 17, 18, and 19. Number 20, is it possible to draw a trapezoid that has two pairs of congruent consecutive angles? Is it possible to draw a trapezoid that has two pairs of congruent consecutive angles? All right, well, it is possible, okay, to have two pairs of congruent consecutive angles. It is? Oh my goodness, yes. We call that an isosceles trapezoid. Here's an isosceles trapezoid. These two angles here have to be congruent, and these two angles here have to be congruent. So look what you have. You have two pairs of consecutive congruent angles. Here's one pair. Consecutive means side by side. So here's one pair of consecutive congruent angles, and here's another pair of consecutive congruent angles. So yes, it is possible. An isosceles trapezoid will always have consecutive congruent angles, all right? So yes, that is possible. Doesn't always happen because sometimes your trapezoids are not isosceles, but if it's isosceles, it's possible. Okay, number 21. Is it possible to have a leg longer than either base? Oh my goodness, yes, definitely. A leg will make your base here real small. Make your base up here real small, and then here's a leg coming down. There. I just drew a trapezoid in which the leg is longer than both bases. Okay? So there it is. Yes, it's totally possible to do that. So yes. Alright, moving on. It's number 21. Number 22. Exactly three congruent sides. Number 22. That is possible. And let me show you how. Watch carefully. if I draw this side here as a length of 2, and then draw this side here as a length of 2, and then draw this side as a length of 2, and I do that in such a way that this angle here is the same as this angle here, then when I draw this line here, this side here will be parallel to this side here, and this side is congruent to this side, congruent to this side. So it is possible to have a trapezoid with 3 congruent sides. Yes, it is definitely possible. Alright, okay, that was number 22. Number 22. Let's move on now to number 23. 23 says exactly 3 congruent angles. That is not going to be possible, guys, okay? And let me show you why. Let me show you why. Let's just say we have an angle here of 60, and an angle here of 60, and an angle here of 60, okay? That's 180. So this angle right here would have to be 180 degrees. That's not possible. Let's make these angles a little bigger. Obviously, let's go with 80. Let's say I've got 80, 80, and 80 degrees. That's 240 degrees. So this angle here has to be 120. Okay? Well, guys, look, please don't ever forget this. When you have a trapezoid, these 2 angles here have to be supplementary because you have 2 parallel lines being cut by a transversal. So somewhere you've got to have 2 angles that are supplementary, here and here. Well, look, guys, if you were to pick up this whole object here and move it down here and make it a little bigger so it fit around all these angles, there's still no way you'd have a trapezoid. Look, if you're saying these 2 lines are here parallel, then these 2 angles here have to add up to 180, and they don't. If you're saying these 2 lines here are parallel, then these 2 angles here have to add up to 180, and these angles here, and they don't. There's only one way you can do this. And you're like, well, Mr. Air, I thought you said we couldn't do it. Well, the only way you can have 3 congruent angles and have a parallel side here and a parallel side here is if you have 90, 90, and 90, and then this would have to be 90, and then you don't have a trapezoid, you have a parallelogram, a rectangle, which is a parallelogram. So no, it is not possible in a trapezoid to have 3 congruent angles, okay? It's not possible. And that was number 23. Alright, let's take a look now at number 24. Is it possible to draw a trapezoid that has congruent bases? We talked about this a little bit ago in a previous problem. It is not possible. It sounds easy, but it's not, okay? Here's your trapezoid, and here's one base, and here's the other base. Now, if those 2 sides are your parallel sides, okay, and you draw these sides here, they're going to be parallel too, if these 2 sides are congruent. And I've told you a little bit ago, okay, you say, well, Mr. Erhard, I'm going to move this side over, like this over here. That's fine. But if this side here is congruent to this side here, then that means this side here, I just drew right here, will be parallel to this side here. It just has to be. So it is not possible to draw a trapezoid that has congruent bases. Now you can draw a trapezoid that has congruent legs. We call that an isosceles trapezoid, but it is not possible to draw a trapezoid that has congruent bases. Cannot be done. Okay, lastly, let's prove theorem. That's a note for pre-calc class. Let me get rid of that. Let's prove theorem 6.18, okay? Let's prove this. This is the theorem that says if you have an isosceles trapezoid, so if isosceles trap, then diagonals are congruent. And you're responsible for this on tests and quizzes, okay? So here we go. Your if part is your given. So you are given A, B, C, D is a what? Isosceles trapezoid. I'll draw it right over here for you. There we go. A, B, C, D. Alright, then we're going to prove that DB is congruent for a second. I'm going to lay out a plan of attack, okay? Now I'm going to do it again to this triangle right here. So there we go. There we go. And there we go. All right, let's pull that down here. So now this triangle here is called DAC. DAC. This triangle here is a B here, a C here, and a D here. Now, let's think this through. If I have an isosceles trapezoid, I know I can state somewhere in my proof that this side here is congruent to this side here by definition of isosceles trapezoid, and I know for sure I can state that this side here is congruent to this side here because it's the same side. They share a common side, correct? And then look, remember, we learned a theorem that said if you have an isosceles trapezoid, the base angles are congruent. So I know this angle here has to be congruent to this angle here. Guys, I've got side angle side congruent to side angle side. These two triangles are congruent. And once I state these two triangles are congruent, then I can definitely state that AC right here is congruent to BD. So that's my plan of attack, okay? So I'm going to slide these up a little bit to give me a little more room. And here we go. All right, number one would be my given, of course. Number two, I can definitely state that AD is congruent to BC, right? Because definition of isosceles trapezoid. I was given that I have an isosceles trapezoid. The definition of an isosceles trapezoid is the legs are congruent. So, definition of isosceles trap. Alright, now let's go on to number three. I can definitely state that DC is congruent to DC. That's the reflexive property. Reflexive. This is really a simple proof, guys. Now I can state that angle ADC is congruent to angle BCD by base angles of isosceles trap are congruent. Okay? And now I can state the two triangles are congruent. So triangle ADC is congruent to triangle BCD. And the reason, of course, is side angle side congruent to side angle side. And now that I've stated that, I can definitely state that AC is congruent to DB, which is what I wanted to do right here in my proof part. And of course the reason is CPCTC. Guys, I hope this homework help video has been a help to you. If you have any questions at all, don't hesitate to call or email.